Hello friends, this is Shivam and welcome to the next tutorial of the series Data Analysis using Python. And in this tutorial we will see how to run a K-means cluster analysis in Python. And the dataset that we are using in this tutorial is the same dataset that we have used previously, the iris dataset from the UCI machine learning repository. And first of all, we will just import all of the required packages that we will be needing to go this tutorial. So we have imported the pandas library, we have imported the matplotlib, we have imported the sklearn and the various functions of sklearn package, and we have also set the parameters such as figure size for the matplotlib graphics. So now let's import all of these libraries all together. Now we will load the iris data. To load the iris data from the sklearn datasets function, we just need to load iris is equal to load iris, and we just need to x is equal to, we just need to convert the data into the pandas data frame. So just pd dot data frame iris dot data iris dot data, and y is equal to pd dot data frame iris dot target. So, and now we will also print the feature columns of feature names of the iris dataset. So let's print it and see. So we are having a problem here. We are just iris load iris and iris dot data. Okay. We just give the command. So we just need to fix the code and iris dot data, and in the same way we just need to. So this is we have loaded the data set into the console, and we have also generated that what are the various feature names of the iris data set. That you can see the sepal length, sepal width, petal length and petal width. Now we will generate the x dot columns is equal to sepal dot length comma sepal sepal width petal length and petal width. So these are the columns of the X data frame, and in the same way we will define the columns for the Y data frame, and that is the targets. So we have defined the columns, we have assigned the column names to the X and Y data frames. So now let's see what is the shape of X data frame. So we can see that the shape of the X data frame is 150 by 4. There are 150 number of observations and there are 4 columns, and in the same way we will just try to see the shape of Y data frame, and it is 150 by 1. So now we will just try to build a model based on the training data set. Build model on the training data set. Now to build the training model, we will just use the KMeans. Let us see how we have imported it above. Okay, so model is equal to KMeans and the number of clusters. We know that we can fix the number of clusters to be 3, because we know that in iris dataset there are 3 classes of label, and so we have decided to keep the number of clusters to be 3. So number of clusters is equal to 3, and now we will fit the model with the X dataset. So features. So KMeans is not defined. Okay. So number of clusters we want to fix to be 3. So now we have fixed a K-means cluster to the model, and we have kept the number of clusters to be 3, and now we fit a model on this. We fit a model on the training data set, and now we just want to view the results. We can view the results by using model dot labels, and you can see that these are the labels and these are the clusters that the K-means model has provided. Now if you want to get the indices, the indices or the number where these all points appear for each cluster, we can also do this by using the numpy, and we have to just to get the indices of points for each cluster. Now what we will do is we will define a function I np dot where model dot labels is equal to I and 0 for I in range model dot number of clusters. So let us see. Okay, it is showing the error, and dot np not models, np dot where model dot labels is equal to I for I in range. Okay, so this is the mistake that we have done over here. We have put it in syntax. So if we want to get the indices for each point, for each cluster, we can use the following command, and we can see that the 0, that is the first cluster, is having the indices number as the following indices numbers, and the cluster number 2 and cluster number 3 are having the following indices number. So now let's move ahead and plot the cluster for both of the predictions and as well as the actual clusters. So now we will just move ahead and we will just define a color map as np dot array, and since the number of clusters are 3, so we will put 3 colors. We have put the red, blue and yellow as the color map. Now we will just plot a scatter plot, plt.scatter with x dot petal length, comma, x dot petal width, and we will define the color to be the color map that we have just built above, and we will give the arguments to be the model labels, model dot labels, and we can fix the size to be 40. And now let's print the scatter plot. So we have just created a scatter plot, and we are just trying to cluster these petal length and petal width into based on the cluster points that we have just predicted. That is the model labels, and we have obtained this chart and now this scatter plot, and now we will just try to plot the actual cluster of the data set x dot petal length, comma, petal width, comma, c is equal to color map, and we will give the arguments to be y dot targets, and we will keep the size to be 40. Okay, so we have done the mistake over here. So this is the cluster for the actual data points, and you can see that we are just doing it in the wrong way, and although the clustering is good, but the color mapping is not good, so we just need to fix the color clustering is good, but we need to fix the color issue. So we just want to convert the zeros into twos and zeros into twos and twos into one. So let's try this, and we will just define one more variable as the pred y. np.choose model labels comma, we just want to 0 to 2's, so we will just put it comma 1 comma 0 comma 2. So, and dot as type np dot int 64. Now we just want to fix the color issue, and we want the ones to be 2's, and we have so now we have defined the number, and now just print the model labels, and we will also print the pred y. So here we can see that. Okay, so now let's try to plot the graph over here, and we will just use the color map. We have used the color map, and we will plot first of all we will plot the original graph plot original graph. So plt dot subplot, we will be plotting both of the graphs on the same line, on the same cell. So plot dot subplot 1, 2, 1, and plt dot scatter x dot petal length comma x dot petal width comma color map C is equal to color map y dot targets, and we just want to fix the size to be 40, and plot dot title plt dot title to be the real clusters, and we will plot the predicted with corrected values, plot the predicted values with corrected values. Now we just want to plot the subplot, and we'll just give it the dimension is 1, 2, 2, and we will again plot the scatter plot x dot petal length comma x dot petal width comma C is equal to color map C is equal to color map with pred y and size is equal to 40 and plt dot title to be K-means classification. It's clustering. So K-means, so we have to just provide it to be, it's okay. So this, so now we change, so now we'll just change the clustering to the labels to the 2, 0, 1, and then we just try to predicted values, and then we just plot the chart. Now that we can see that the clustering is good and the code of the and the issue of the color is also fixed, so we can see that the clustering is quite good, although it is somewhat distributed, and it has also it is also not able to distinguish between some of the data points, but the actual level of clustering is quite good. So this is how we can run a K-means clustering in Python, and I hope you have enjoyed the video, and thanks for watching. Please subscribe.